The Artemis program is humanity's ambitious return to the Moon, not just to visit, but to stay and prepare for the journey to Mars. Artemis I proved that the Space Launch System and the Orion capsule weren't just concepts, they were a reality. It was a flawless demonstration of the technology that will eventually carry us to the deep dark of the lunar night. Today, the world is watching as Artemis II dominates the headlines. As the first crewed mission of the program, it's the ultimate stress test. 4 astronauts, a trip around the far side of the Moon, and a journey farther than any human has traveled in over half a century. But while Artemis II is about the journey, the mission that follows is the one the world has been waiting for, Artemis III. This is the bridge between proving we can fly there and proving we can stay there. Currently targeted for a launch in 2028, Artemis III is shrouded in as much mystery as its excitement. In this video we are diving into every piece of Artemis III mission data available as of winter 2026. From the complex orbital mechanics to the new suits that will walk the surface, this is everything we know about humanity's return to the lunar soil. The goal of Artemis III isn't just to repeat the achievements of the Apollo era. It is to fundamentally change our relationships with the Moon. While the missions of the 1960s were about proving we could get there, Artemis III is the opening chapter of a permanent human presence. To achieve this, NASA has selected a destination that remains one of the most mysterious and treacherous locations in the solar system, the lunar South Pole. This region is a radical departure from the flat sunlit plains explored during the Apollo missions. The South Pole is a landscape of extreme contrasts, featuring peaks bathed in near constant sunlight and deep craters that haven't seen a photon of light for billions of years. These permanently shadowed regions are some of the coldest places in the known universe, but they hold the key to our future in deep space. The primary reason for targeting the South Pole is the presence of water ice. While scientists had suspected its existence for decades, it was NASA's LCROSS mission in 2009 that provided the first direct confirmation. By deliberately crashing a rocket stage into the Cabeus crater and flying a sensor-filled probe through the resulting debris plume, NASA physically detected over 150 kilograms of water vapor and ice crystals. Since then, the Lunar Reconnaissance Orbiter has spent over 15 years creating a master map of the lunar surface. By constantly scanning the poles, LRO has pinpointed the exact locations where temperatures never rise above freezing, creating a detailed guide of cold traps where ice has likely been preserved for billions of years. This data allows NASA to see exactly where the ice is buried, how much sunlight hits the crater rims, and most importantly, where the terrain is safe enough for a massive starship to land. This discovered ice is the most valuable resource in space. If we can harvest it, we can process it into oxygen for breathing and hydrogen for rocket fuel. By learning to live off the land, the Moon transforms from a distant destination into a critical staging ground, a deep space gas station that will eventually fuel our journey to Mars. Beyond the resources, the South Pole is a scientific time capsule. Because the ice and soil of these shadows have been frozen for eons, they preserve a record of the early solar system and the history of the Sun. Artemis III is designed to test our ability to survive and work in these harsh conditions, proving that we can build habitats and operate machinery in one of the most unforgiving environments we have ever encountered. This mission is the foundation for a sustained presence on another world. To make a mission this ambitious work, NASA isn't going it alone. A massive team has been assembled to build the tools needed for the job. SpaceX was chosen to build the giant lunar lander. while a company called Axiom Space was brought in to design the high-tech suits the astronauts will wear on the surface. Together, they have developed a mission plan that looks more like a high-stakes puzzle than a simple flight to the moon. Currently targeted for 2028, the plan requires a handover in deep space that has never been attempted before. It actually begins without any people at all. Before the astronauts even leave Earth, SpaceX must launch a series of tanker ships to create a fuel depot in orbit. Once this gas station in space is ready, the Starship lunar lander will launch, fill its tanks, and head toward the moon to wait for its crew. The meeting point for this mission is a very specific path called a near-rectilinear halo orbit, or NRHO. Instead of a simple circle around the moon, this orbit is a long, egg-shaped loop that balances the gravity of the Earth and the moon. NASA selected this path for two vital reasons. It provides a nearly constant line of sight to Earth for non-stop communication, and it keeps the spacecraft in permanent sunlight, ensuring the solar panels are always generating power. A crew of 4 will launch aboard NASA's Orion spacecraft and travel several days to reach this meeting point. Here they will dock with the waiting Starship lander. 2 astronauts will move from the Orion capsule into the Starship, while the other 2 stay behind in orbit to keep the main ship running. Once the 2 ships separate, the Starship begins its solo descent toward the lunar South Pole. This is a high-stake maneuver where the ship must find a safe, flat spot to land among the long dark shadows of the lunar surface. After touchdown, the crew will spend about 6.5 days living and working on the moon. When their work is done, the Starship will blast off again, meeting back up with their teammates in the NRHO orbit for the long journey home to Earth. The sheer scale of the hardware required for Artemis III is a testament of how much rocket science has evolved since the 1960s. The backbone of the journey remains the Space Launch System. This is currently the only rocket in the world powerful enough to send the Orion spacecraft and its massive upper stage into orbit, providing the needed force to propel the crew toward the moon. If you want to understand the engineering behind this rocket, you can check out my previous video where I provide a full breakdown of the Orion vessel, from the launch abort system that ensures crew safety during ascent, to the crew module where the astronauts live, and the European service module that provides life support and maneuvers the ship once it reaches deep space. However, once the crew reaches lunar orbit, the mission relies on a completely different beast, the SpaceX Starship Human Landing System. This is a modified version of the Starship currently being tested in Texas, specifically redesigned for the lunar environment. It's important to note that because much of the Starship's internal engineering is not publicly shareable, we only have a partial view of what this vehicle will truly be capable of. What we do know is that the lunar Starship is massive, standing roughly 50 meters tall. Unlike the tiny Apollo lunar module, Starship offers a spacious cabin where the 2 astronauts will live and work for nearly a week. Despite the secrecy, we have seen major progress. As of late 2025, SpaceX has successfully completed 49 major milestones required by NASA. These are proven hardware successes, including the docking system, qualification of the docking adapter that will link Starship and Orion. Based on the flight-proven Dragon design, this system has been validated to ensure a safe transfer of crew and supplies in deep space. Elevator and airlock. NASA astronauts have completed crew-in-the-loop testing of the Starship's elevator and dual airlock system, practicing exits in pressurized suits to ensure a safe transition to the lunar surface. Raptor engine tests. SpaceX has successfully demonstrated cold start tests of the Raptor engines, proving they can ignite after being chilled to the extreme temperatures of deep space. They also completed a 289-second throttle test to simulate the long controlled descent to the moon. While the hardware is maturing rapidly, one of the most exciting and difficult milestones is still ahead: the in-space propellant transfer flight test. Targeted for 2026, this mission will involve 2 Starships docking in Earth's orbit to transfer massive amounts of fuel. The gas station in space concept that is essential for reaching the moon. While the full technical manuals remain behind closed doors, the successful flight tests we have seen so far prove that the era of the super heavy reusable lander is no longer just a drawing. It is the vehicle that will carry us into the next era of exploration. The final piece of the Artemis III puzzle is the spacesuit. NASA delegated its development to a commercial company, Axiom Space. The spacesuit is developed in a surprising partnership with the luxury fashion house Prada, and it is a massive leap forward from the Apollo era. While the 1960s suits were famous for making astronauts bunny hop because they couldn't easily bend their knees or waists, the X-EMO is designed for true mobility. Using advanced soft and hard joints, astronauts will finally be able to walk naturally, kneel to pick up rocks, and perform complex science tasks, with a range of motion never seen before on the moon. NASA established the foundation for the X-EMO through its own X-EMO prototype development. Axiom used the data, expertise, and feedback from the program to reduce technical risks. Axiom has also solved a major historical problem: fit. Unlike the custom-made one-size suits of the past, the X-EMO is modular and adjustable. It is designed to fit 90% of the population, ensuring that a diverse crew of both men and women can work comfortably and safely. With high-definition cameras mounted to the helmet and rear entry design that allows astronauts to climb into the suit in minutes, the X-EMO is the high-tech uniform for the next generation of explorers. To bridge the gap between the Moon and Earth, Axiom has partnered with Nokia to integrate the first ever 4G LTE cellular network directly into the suit's avionics. Developed by Nokia Bell Labs, the Lunar Surface Communication System will allow Artemis III astronauts at the Moon's South Pole to share real-time HD video, transmit telemetry data from their spacesuits, and communicate with mission controllers back on Earth. This lunar communication system will create a 4G LTE network connecting the spacesuits to the Artemis III human landing system, from which a direct-to-Earth link will relay all communications to the mission control at NASA's Johnson Space Center in Houston. As we move into 2026, the components for Artemis III are finally transforming from blueprints into flight hardware. NASA is in full production mode. At the Kennedy Space Center, the SLS core stage and the Orion crew module are undergoing final assembly. The hardware that will actually carry the next generation of explorers is now physically sitting in the hangar. However, the landing itself remains the mission's biggest question mark. SpaceX faces a high-stakes 2026, with the first ship-to-ship propellant transfer flight test serving as a critical technical hurdle. But the ultimate test comes after. SpaceX must successfully perform a full uncrewed demonstration landing and liftoff on the Moon. This skeleton ship must prove it can survive the South Pole and return to orbit before NASA will ever risk putting a crew on board. NASA is officially holding to a 2028 launch. But with official refueling and the uncrewed demo still on the horizon, many in the industry wonder if even that date is ambitious. So I want to hear from you. Do you believe we'll see boots on the Moon in 2028? Or is another delay inevitable? Let me know your thoughts in the comments.